I posted a video on binary operation, all right, and this was the question. The operation is defined on the set of real numbers by A operation B equals A plus B all over A minus B. Yes, if you've seen this video. Then in the comment section, someone asked me to find the inverse of this operation. First of all, write down our inverse equation, which is written as A operation A inverse is going to be equal to the identity element. All right, and I have done a video explaining this already, so we just take it from there. We do not know what the identity element is, so we must find the identity element first. Identity element is written as A operation, the identity element, or the E is always equal to what? A. A operation E is always equal to what? A. So we take this identity element and then we do the substitution. So our A operation E is going to be equal to A plus E all over A minus E. A minus E, which is equal to what? A. All right. So this is what we wrote. A operation E is equal to what? A. So we are just substituting. So first of all, we are doing A operation E, and that's what we've done here. And then this is equal to what? A. So how do we solve this? Easy. We treat this as what? Over 1, and then we cross multiply. All right. So 1 times the whole of this gives me A plus E being equal to what? A squared, because it, all right, being equal to A bracket open A minus what? E. So we expand this. We are having A plus E equals what? A squared minus what? AE. So we are interested in E, so we bring it here and we maintain this E. So E plus AE is equal to A squared. Then this A has to go because we don't need it, minus what? A. So we factorize E out and we get E. Then we have 1 plus A is going to be equal to A squared minus what? A. We divide by the coefficient of E, which is what? 1 plus A. So we have this 1 plus A dividing that, then 1 plus what? A. Okay, so this cancels this. Then we have, at the end of the day, we have E is going to be equal to A squared minus A all over 1 plus A. Now this is where I want you to pause to think about this. We have our identity element, which is going to be equal to what? A squared minus A all over 1 plus A, which is totally wrong. Not because the solving is wrong, but you cannot use this identity element to find the inverse. All right. Reason being that the identity element is not unique. It is dependent on what? The value of A. All right. And looking at the videos I've done, the identity element is always either 1 or what? 0. These are the two numbers we have for identity elements. All right. So any other thing apart from this has no inverse. Okay, it's literally impossible for you to have an inverse for an identity element which is not unique and the value is dependent on, a variable like A. Okay, so what I mean is that if A, so let's try this. If A is equal to 1, we have 1 squared is 1 minus 1, which is what? 0. 0 divided by whatever is 0. So when A equals 1, then E is equal to 0. All right, makes sense. But now what if A is equals 2? So we are going to have 2 squared, which is 4 minus what? 2. 4 minus 2 is what? 2 all over 1 plus 2, 3. So 2 over 3. You see, when it's 2 over 3, the value is changing. So we cannot work with this. So therefore, this problem we see over here, this operation has no inverse. So that's our conclusion. All right. So this binary operation has no inverse. Thank you very much.